I've been flying quads now for about 5 or 6 months and have quite a few of them. But one of the things that I've not tried yet is a MultiWii board. I've got models that have the APM 2.5, which you can see in some of my other videos. I have a model that uses the KK 2.0 flight controller board, but I've never tried the MultiWii, which is actually in the middle of this quad. Big thanks to Banggood.com, who sent me this board to try, and I'll post the link of the download from those guys. But you know, thanks again to the gang up there for sending me this, because it's something I've been interested in having a crack at. But until you guys sent me the board, I kind of didn't have all the bits and pieces I need. This quad that we're looking at here, that it's actually installed in, it cost me about $7, because I had the motors, I had the ESCs, I had the receiver. The only thing I didn't have, I even had the power distribution board from another project that I didn't use. The only thing I had to buy was this copy of the DJI Flamewheel 330 frame. It was a copy from eBay. It was about $7, and obviously the MultiWii board itself, which the guys at Banggood sent to me. So another quad for $7 out the spares bin, I think is pretty good. So what I was going to do was kind of go through the MultiWii board. One of the things that I found when I was trying to figure out how to configure this, there's no real clear instructions of how you do it. There's lots of people showing these boards flying, but in terms of how you configure them, what you have to do, the bits that you need, the programs that you have to run, it isn't a simple ABC. So I've put this video together to show you how I've got this this quad flying well, so that you don't have to go through the same amount of trial and error that I did. Initially, I was put off by the MultiWii because of a couple of things, really. The first main one was that because there are so many versions of the board and there's so much code flying around, there's so many different programs and other bits and pieces, it seemed very daunting. Compared with the KK 2.0, where it's all done via the onboard screen, there's no additional software needed unless you want to flash the firmware. And compared to the APM 2.5, where all the configuration is done through one interface, the fact that you had to use several programs to configure this and essentially edit the parameters in what looks like a program looked a little bit daunting. But it's not as bad as you think. We'll go through this as part of the video. So what we're going to cover, we're going to go through the features. I'll talk about the board and compare it with the KK 2.0 and the APM and what I found with it. We'll also go through what you need to actually set this sucker up. There are some extra little bits and pieces that you might need. If you don't have things like something called an FTDI connector, which is the thing that you need to connect this board to USB, then you'll need one of those. And we'll go through all the other bits and pieces. There's not much. And then we'll talk about how you upload and configure the program to this board. I'm actually going to post a link to the sketch, which is what you call the program that goes onto this thing. It kind of comes pre-written and you just configure it for this particular version of the board. We've got a CRIUS SE version 2, or CRIUS, not sure how you pronounce it, SE version 2 of the board here. And I'm going to publish a download link to the sketch that I'm actually using on this exact model, so that rather than you have to figure it out yourself, you've got one that's ready to go. Once we've done and programmed the board, I'll show you how to configure it, which is in a slightly separate program, and at the end of that I'll actually show you this thing flying around so you can see it in action, so to speak. So the first thing we'll do is talk about what it is. The nice thing about this board, I'm not sure if you can actually see it in the middle of this quad. That's the board there with the green and yellow bits and pieces on. The way I have this board set up is this is the front and that's the rear. So we're actually looking at the side here with the FTDI connector and the actual connector for the Bluetooth module, actually, which I'll have in here. I'll do another video on another day. It's really very small. So whereas the KK 2.0 is a little bit wider, here there's actually room for you to kind of place additional bits and pieces. And actually, if I turn it around to the other side, you can actually see here the Bluetooth adapter, which allows you to configure this wirelessly, which we won't go through in this video. I'll do a separate one on how you set that up. The nice thing about this is it actually has more sensors on than the KK 2.0. So this thing has a gyro, accelerometers and a barometer as well, so it can sense its movement. It also has a compass in, so you can actually lock the direction to the compass heading, which kind of makes it very, very solid in flight. Or you can actually use the barometer to try and maintain altitude. And with all the barometers in these things, they're not fantastic. The other thing about this as well is it's cheap and cheerful. It's kind of $30 or less. So if you compare it with things like the KK 2.0, it's slightly cheaper. If you get it with the FTDI adapter, you'll pay about the same price. Now, it doesn't have the onboard screen, but it does some things that things like the KK 2.0 doesn't do. So for example, you can buy the GPS module that will plug into this, which allow you to do GPS hold and also return to home in the event of a radio failure. You can also do things like put on the Bluetooth adapter, which will allow you to configure the board from things like an Android device or a PC wirelessly. And you can, if you really want, you can actually buy a display. That's the display at the front. I haven't got that quite working yet, and that's, I think, another $5. So all the little things that add on to it are very cheap and cheerful. So it's, although the basic thing gives you enough to fly and have a great experience with, you can add additional sensors and boards to make it into exactly what you want. Like I say, the only downside with this is because it is so modular and flexible and can do so many different things, it can appear a little bit daunting. The last thing I'll mention here in terms of features is this board will do something that the other two can't that I've seen, is actually allow you to build a model with only 2 rotors and 2 servos in the middle. So you can fly a model that looks similar to the gunships and things like Avatar. That's actually available through this board, and there is part of me that now wants to get another board and have a crack at making one of those. So that's a quick overview. Let's look at what you actually need to program this thing. So what you'll need to configure the board is 2 things really. You'll need a PC that's running the software, or a Mac that's running a PC emulator that's running the software, and you'll also need one of these things. This is an FTDI to USB board, and the way it works is that this actually plugs into the board at the side, and then the USB cable plugs into this and goes into the PC. There's no, on this board, automatic way to plug it in. There's no, some of the other Arduino based MWB boards have a USB connector on part of it. This one doesn't, so you need this little guy if you're going to configure it. The way you put it on is, bear in mind, this is the front of the board and this is the back. The front of this board is denoted by a little arrow, is that you push it onto, you can see these 6 pins on a green connector. You push this FTDI board onto those pins, and then you can plug that bit into the PC and you're ready to go. The next thing we'll do is we'll actually look at the software that you need to program the board. The first is the Arduino application. You download this from arduino.cc/en/main/software. I'll put it up on the screen and I'll put it in the notes at the bottom. So you go there to download this. This is the Arduino code that you can use to upload any programs onto an Arduino based board. It's not specific to the MultiWii, and we'll look at that in a second. The second thing that we're going to look at is the MultiWii configurator, and that's a board that you actually use which has a little artificial horizon in it and all different bits and pieces. It's a graphical interface to actually configure the board to set it the way that you want. So the 2 bits of software, I've put that on the desktop here for simplicity. This is the first one, the Arduino 1.0.5 that we're downloading from arduino.cc, and if you search on Google for MultiWii 2.1, it'll point you towards a code.google.com address, which is now on the screen, and that's where you download this one from. And these are the 2 that I've used to actually configure this board in front of me. We'll look at the Arduino one first, but I'm just going to show you something in the MultiWii 2.1 directory. So when you download it and you expand it, you actually end up in here with 2 things. This MultiWiiConf 2.1 is actually the program that you use to configure the board. What it also comes with in this other area, MultiWii, and I've put a link in the bottom to this actual configuration file that I'm using here for this board, so you don't have to edit your own. But this is all of the code and the settings for all the different parts of this MultiWii SE version 2 board. So what we'll do is we'll actually start the Arduino application. Click on Arduino. Take a second to start up, and once it's started we're going to do two things. One is change the board type to the board we're actually using, and we're also going to open the sketch. Bear with me. Into that directory where we're looking before, and there it is. So we'll open that up, and here's that sketch program basically listed out in front of us. Now each of these tabs is that one of those INO or .h files listed out. It looks really complicated, you don't have to worry about any of them. The one you're interested in is this guy called config.h. In config.h there's the basic settings that you need to tweak in order to tell the board what you're going to be flying. If you read through these comments which are throughout the file, it makes it quite straightforward actually. What I'd suggest is that if you just watch this, it kind of makes sense, or you can download the file without having to worry about it, but it's worthwhile kind of scrolling through because there's lots of configurable stuff once you've got the board running that you tweak. So the basic setup we'll look at now. If we scroll down here, anything, the way this works is anything with a double line in front of it is ignored. Anything without a double line is read as part of the code when it creates the code to go into the board. So it's a quad X, min, max throttle, min command, iTunes. You don't need to leave those as they are. And we've also defined the board as a SE version 2, and that takes care of pretty much everything. So now we've got that, we go into Tools, Board, whoops, and we can select this board here, the Arduino Pro Mini 5V 16 MHz 18 MHz 328. This is the board that matches the technology on the SE version 2 board. So what we do is we click that one, and then what we do is, while having the board connected to the serial link, and again that was not something I had to configure, Windows did it automatically, we click File, Upload. Now what happens now is it compiles the sketch, it creates all the settings that are in here, tests them, make sure there's no errors in the code, and then once it's finished it flashes it onto the MultiWii. Now when this is finished compiling, it'll fail, surprise surprise, because we haven't got it plugged into the copter because mine's already flashed. But I just want to show you how long it takes to do a sketch. Now this is running on a very small little netbook that I carry everywhere, so it takes a while, but there's the error. So once this is done, if it worked, it will all be green at the bottom and it will say upload complete. And once that's done, then we would unplug the board, unplug the FTDI connector, and the board is set. So the next part of the process is to connect the board up to the PC and actually configure the software that we've just uploaded. So what we're going to do is we're going to pop on the FTDI connector again. It's a little bit fiddly the way I've got the board mounted, like that, and the other end we're going to plug into the PC. So we'll plug this into the side of the PC, and you'll hear the little noise say that it's seen it. The next thing we'll look at is how you then configure the quad. So we're going to go into the MultiWii 2.1 directory, into MultiWiiConf, and then into the directory for the operating system that we're running. It's Windows 32 here. So we click on it, MultiWiiConf, and it will load up. Now this is version 2.1. You might see 2.2 on a couple of other videos and whatnot. The display is slightly different. Version 2.2 has a artificial horizon, but I actually quite like this interface. It's very useful to help set it up. So here we are. You can see that COM7 is the COM port that it can see the USB connection via the FTDI board onto the MultiWii. That's now been flashed with this program. I'm going to click on that, and there you see a lot of things go green. So if I click on read, and start, what we actually do is we're suddenly looking at the quadcopter itself. So here are all the PID settings. Over to the right we have the settings on the receiver. On the bottom we have a list of all of the settings. So if I move the quad about, you can actually see it moving in real time on the display. If I twirl it round, you can see all the sensors working and all those bits and pieces. So that looks like it's working. Going to talk a couple of bits and pieces in here that you might want to think about when you're setting yours up, because this is the kind of a similar interface to some of the other configuration things for things like the APM 2.5, and this stuff is the kind of stuff that you'd set up through the menu interface on the KK 2.0 board. A couple of comments I'll make about this. First of all is when I put the machine down flat, you'll see that everything kind of stops moving with the exception of this wavy line here. This is actually the altitude. The altitude sensor, the barometer on this board, like most of these boards, isn't fantastic. It will keep you within a a reasonable several feet of altitude in the air, maybe a bit more. If you're expecting it to keep you 6 feet off the ground perfectly, it's not going to do that well enough. I've got mine covered even with a bit of foam as per the the wikis and the other bits and pieces. It's still, even in a room without any breezes, is jumping around, but that's just the way it works. You can see here that there are 3 sensor sets being picked up by the display: the accelerometers, the barometer, and also the magnetometer, which gives us our heading. You can see the settings here for the radios or the different channels. You can actually set those yourself as well if you kind of want to play with it in here. And you also have in this section the ability to kind of decide which piece of technology you want on in each flight mode. So that's like the difference between kind of acrobatic and stability mode on some of the boards. So first of all, let's talk about the PID settings. The basic PIDs are pretty much what's at the top for 4 and 4. I found that I needed to increase the proportional settings on this one quite a lot. I found that the yaw or rudder was very soft for me. I also improved the rate. Normally when you have the board from basic, it's 0 and 0 in rate. This rate is for roll and pitch, and 0 is kind of new for newbies. If you're just learning, it's a great setting. 1.0 is the maximum, and that is super aggressive. I found 0.4 is kind of soft acrobatic. 0.7, 0.8 is kind of hard acrobatic. I've had to put my rudder up to 0.9 just to make sure it's kind of snappy enough but doesn't overcorrect itself. That's why I've kind of increased the proportional and derivative settings on the PID for the yaw. In my setup here, in the low of my auxiliary one is actually wired in, as we can see in this diagram. So all the settings down the left hand side here are for how you wire this thing up. So you have the throttle at the top, and then you have the other channels underneath. Then on the right hand side you would have the things like the Bluetooth would plug into the top port, the bottom port is for the FTDI, and the port at the top is for things like the GPS or the OLED display, and the outputs at the bottom are for the motors and or servos if you're using it. So I've got my AUX1 actually configured to be one of 3 readings, so I actually have low, mid and high. So the way I have it in low, I have no help, that's just me flying the board. In the mid position, it is the accelerometer, which is like the stability mode on a KK 2.0 board. When you take your finger off the sticks, it will auto level. And in the high, it's the accelerometer and the magnetometer, so it will actually lock onto a heading, and it will use that to kind of maintain the heading, which is kind of handy. It's kind of like a super duper gyro. Not using the barometer at the moment, I'm too near the ground. The sensitivity of the barometer and the stability of it isn't good enough for me to kind of expect that to hold the thing in place. Now the way you use this is, if you change any of these settings, you kind of click on a number, and then while you've got the mouse button clicked, you pull up and pull down, and then once you've changed it to what you need it to be, you click on the right button to then write it back to the board. I would always suggest that when you've written it, you then re-click on read to reread the settings back in. I'm going to reread it without saving it, so it goes back. And then that you're guaranteed that you're checking all the other bits and pieces, and that it has saved it properly. A couple of things I've mentioned in here. I found that once I'd set this up to actually arm the board, you pull the throttle down to the bottom and to the right. I had to extend the end points of my low throttle, and I also had to extend the end points of my rudder left and right very slightly on the radio to get it to arm, but then it was fine. I like this display in the top right hand corner because the way it's set up is that the direction of the stick should mirror the direction of the bar. So for example, when I increase the throttle, I should see the bar go up, and decrease, the bar goes down. When I push the rudder to the right, I should see it go up, and when I push it to the left, I should see it go down, and vice versa. It's a very easy display to make sure that you need to set up. I had to actually reverse 2 of my channels on my Spectrum radio to make it work. So hopefully that makes sense. What we'll do is we'll close the COM port, we'll close the application, and we'll go out and we'll show you what this thing's like in a hover. So as you can see from the flight here, it's a very stable, has a slight drift, which I'm going to do another video show how you correct and do those bits and pieces for auto level, but very nice control. Probably feels slightly more controlled than the KK 2.0 does, and here is pretty much maximum rudder that I'm turning around in, and you can see it's still not lightning fast, but actually for hard acrobatics I'd probably struggle a bit, but for the kind of fast flying that I kind of do, it's absolutely fine. So in summary, a great board. One I'm definitely looking to use again for another project. Nice and small, nice and cheap, very expandable. Takes a bit of thinking about to get it set up, but it's actually not as complicated as it first appears. And finally, another big thanks again to banggood.com for sending me this board to try. It's been a lot of fun. Thanks for watching, subscribe, post any questions or comments. Happy flying.